Hello and welcome to this technical video session. My name is Talis Kousouris and I'm a Senior Applications Architect within the Red Hat Professional Services. The video is about setting up federation between two Red Hat service meshes. And a service mesh is basically the technology which allows microservices to communicate securely without having to have the security enabled within the microservice. It defines routing between microservices and it enables the observability of the communication between microservices. So without further ado, let's see how federation can be set up. Now, all the information that we will talk about today is recorded in this GitHub repository, so all you have to do is clone the repository and update some of the scripts that are available. There are some prerequisites, so you will need 2 instances of either the code-ready containers running locally or 2 OpenShift clusters 4.6 version 4.6 onwards. You will additionally need the OC binaries for these 2 clusters and pass capability to run the scripts. Now, once you clone the repository, you will have a script, which will basically have content of the locations and tokens to connect to this cluster, so you will need to provide this in the script based on your cluster setup. Furthermore, you will need to ensure that the clusters have the appropriate operators enabled, because the operators are the ones that they will set up the service mesh in each of the clusters, and following from that the federation between these 2 service meshes. So let's do that as well. So first we will log into the East cluster and we will apply the subscriptions for the required operators, and then we will do the same thing on the West side. And this cluster probably is taking a little bit longer because this is the first time that we are deploying the operators. In the meantime, you can see now we can see basically the operators subscriptions being applied. And we see the operators are available. With that out of the way, we will run now the script which will set up the service meshes and the federation amongst themselves. Now the setup, as it mentions here, is an AWS setup, and that is because there's some configurations in the script which are specific to the OpenShift classes running on top of an AWS infrastructure. When we run the script, we will first create control plane namespaces on the East and West clusters. After that, we will create the service mesh control plane resource, which the operators will pick up and set up the service mesh on each side. And then we will create the data plane namespaces where the applications federated will be deployed eventually, and the appropriate service mesh role resource, which basically registers these namespaces with the appropriate mesh. Finally, we will configure the peering setup between the West and East meshes, and to do that we will share secrets. These are required in order for the communications from the East to the West and vice versa to be accepted and validated. And we will set up the service mesh peer resource, which will define the authentication and connection between the two meshes, as well as the export and import of the appropriate service. And with that setup, then we will verify the peering setup. We will also deploy the application on both the clusters, and we will check that the federation working on the Kiali UI interface. Okay, so let's start. Okay, so control namespace on the east side, control namespace on the west side, and first we'll create the federation setup on the cluster, the east cluster. So this will be the namespace and the mesh, creating the project for that, and then the service mesh control plane resource with the additional egress, so we can communicate to the west mesh, and as well the additional ingress, so we can be communicated from the west mesh for the purpose of the federation. You can see also this annotation here, which is, as I said, required to exist in order to discover the service on an AWS cluster. After that setup, and we can see the condition of the east mesh is successful, we create the namespaces for the federation, for the applications, and these have been set up in the service member role, so they can be part of the east mesh, and we can see also that the service member role is correct. Now we move on to set up the service mesh on the west side. Again, we set up an egress, additional egress gateway, so that we can communicate to the west mesh, and additional ingress gateway to have communications coming from the east mesh to the west mesh. And again, the annotation, so we can identify the AWS load balancing service for these communications. We set up a service member role for only one data plane namespace. This is the only one on the west side that we require, and we wait for the west mesh to be operational. So the operator right now takes this resource and creates the appropriate component. Okay, so we can see the conditions have been met. And now we will move on to create the actual data plane namespaces on the west side, and we will actually create the West Travel Agency. That's the only namespace on the west side, and we can also check that the service member role now is successfully, its conditions successfully met, and that means that namespace now it's part of the west mesh, and it's ready to be managed as part of the mesh. Okay, so now we'll begin creating and configuring the peering between the meshes. The first step is to actually share root certificates between the meshes, so that when communications occur from the east to the west and the west to the east, these are validated and accepted. So first we go to the east side and extract the root certificate, and then we will go to the west side and import this certificate into a config map, and again we will extract the certificate on the west side and then import it on a config map, on this config map west CA's root certificate on the east side, whilst the other one I think it is east CA root certificate. Next, we will actually retrieve the AWS load balancing addresses, which are required for the service mesh peering. And now this is the east address, the A35, and this will actually be utilized on the peering configuration on the west side. We will also get the AWS load balancing address, this A3053 on the west side, and we will use it in the configuration on the east side, service mesh peer. And now we'll do the service mesh peer configuration and the service import and export. So we first do east to west, so this address will actually go to the east side, so we can communicate to this side, And also you can see here the certificate that we created earlier being used, and the imported service, which is the travel agency discounts. This is the service to be imported. And now we go to the west to east service mesh peering, and there should be the A35 address there used. And you can see here the A35 address is used. That means from the west to the east we will communicate to another address, and we will use this config map to get the east CA route certificates. And again, we will basically get the exported service defined here. And this service basically will be available to be communicated and imported on the east side, as we saw earlier. And now with these two set up, we will verify the peering connection east to west is working. And we will see here basically that the connection is up right now. The two meshes are connected, so the federation has been successful, and the two meshes now see each other. And with the two meshes now having the federation working, we will deploy the applications. The application demo is a travel agency demo, and we will basically have microservices. We will see them just now being deployed on the east side. So these are the microservices, and there will be travel agency and travel portal microservices, as well as a discounts microservice on the east side. And this will be part of the east mesh. On the other hand, on the west cluster, on the west mesh, we will basically apply on the west travel agency the deployment of the discounts microservice that we've exported as well. Okay, yes, so we can see this, the service, the microservice, the discount microservice is being deployed. And now we will verify visually the setup by checking the setup on the east side and the setup on the west side through the Kiali user interface that is available on the control planes on each side. So this is the east side, and this is the west side. Okay, so we will check the throughput request, and then we'll also check by namespaces. Okay, so what we can see on the east side, that there's basically a travel portal namespace and 3 microservices here communicating to the east travel agency and namespace, which is again running on as part of the east mesh. There's a discount service here, a local discount service, but also a remote discount service. Okay, and if we maybe remove this, should be able to see it a bit more. Yes. Okay. As we can see, actually the service mesh on this side is making requests to the remote discount service, so that's running on the travel agency, sorry, the discount service that runs on the West travel agency, and we can see this also on the Kiali user interface of the service mesh control plane of the West side. See the graphs? Yeah. Okay. So we can see the requests coming from the East travel agency, which are on the East mesh. So the federation has worked, and now we have two service meshes with multiple microservices communicating, allowing the communication of the microservices between the meshes as if they were part of the same mesh. So I hope you've found this useful. As I said, this information are on this GitHub repository, so you can try it out on yourselves. Thank you.